calculate the correlation value using the formula, the correlation value tells us several things. It tells us the strength of the correlation, it tells us the trend, and it tells us the direction. The strength of the correlation, we can kind of look at this scale down here. The R value, the correlation coefficient, is always between -1 and +1. The closer the value is to +1, just indicates that there's a strong positive correlation. It's actually perfectly linear. Each of the points fall in a straight path. You can draw a line through every single point. If the correlation coefficient is -1, it has the same meaning, except it's just decreasing. So +1, positive correlation, -1, negative correlation, very strong. And as we move away from those values towards the center, towards 0, it just indicates no correlation at all. So here I have two examples with two different quantities. Remember, the x-axis is our independent quantity and the y-axis is our dependent quantity. So in this graph, we're comparing mumps and measles. In this graph, we're comparing time in months to age. So you don't have any other background information. But you've noticed in the second graph, the R value is quite high. It's very close to 1. And if we observe each of the points of the scatter plot, they're very close to this line. And this line is called a trend line. The closer the points are clustered together and the more related the points are, the higher the correlation. So these are nearly perfectly related to each other with few exceptions. If you look at the first graph, the correlation value is negative, so that indicates a decreasing trend. And we can see that overall in the points as we observe the points from left to right. But it also tells us the strength is not terribly strong, right? It's closer to the middle here, which anything above 0.5 in this direction to probably 0.75 or -0.5 or -0.75 is more moderate. So this is a more moderate negative relationship or a moderate negative association, those two values. And so the correlation value really helps tell us how strong the relationship is. It can tell us the trend and the direction as well. And so what we would like to do, we have an example here about gestation and average longevity. So we want to determine, is there a relationship between the gestation of a sample of animals and the average longevity in the, in years for a random sample of animals. And so for this, similar type of question as we looked at in section 2.4, determine the nature of the relationship between longevity and gestation with data in the table. We could simply just plot a scatter plot, look at the scatter plot and determine if it's positive or negative. But what we would like to do is get a more accurate picture of the relationship and to really determine how strong is that relationship. So to do that, we're going to calculate the correlation value. And I'm going to show you first how to calculate that correlation value by hand. And by hand, I mean using Excel so we can kind of gather the data quickly. And then I'm going to show you how you can calculate it using your calculator as well. So we're going to look at that first. Now, when I go to Excel here, I went ahead and copied the formula over so we can kind of talk about the components. In this formula, there are several things that we need to know what they mean so we can be successful at calculating the R value. R is just the correlation coefficient. N represents the sample size. So that is the number of pairs of data that we have. In this case, we have five pairs of data, so N would represent 5. This symbol that looks like a kind of a funky looking E is the Greek symbol for summation. So we have to add something together. In this case, in the first part of the formula, we're adding together the products of the gestation and the longevity. And then we're subtracting the sum of the x's, so the sum of all of the gestation values, the sum of all the y values. So that's just the numerator, right? A formula is just instructions to tell us what to do to arrive at an answer. And so we're going to talk about how we find those answers. So what I'm going to do, since I know I need to sum the x values, I'm going to go ahead and do that here. These 5 values represent my x values, so I'm going to say equals sum. I'm going to tell Excel some instructions, highlight the x values, and enter. So 883 would be the value of this sum of x. And then equals sum again, and I'm going to select all the y values, and that's the value for the sum of y. Now, the other components, I'm going to actually have to type some information in for the table. So if I need the sum of x times y, I might here write x times y, and I'm going to give Excel some instructions. Equals the x value times the y value. So if you've never used Excel before, I'm just giving it a command. B2 is column B, cell 2. C2 is column C, cell 2. Enter. And then if I copy that down, it's going to multiply. So that's the next row, the next row, the next row, and the next row. So those are all the products of the gestation and the longevity, and I want to sum those together. So let's sum those together. So this is the sum that represents this value, 16,558, represents the number that goes here. So that's just the numerator so far. And then in the denominator, I want to find the sum of the squares of x's. So that means if I take x squared, that means equals, I have to take this 105 and I want to square it. So that number is 105 times 105. And I want to do that for all the values. So this 12,554 is 112 squared. And I need the sum of all those numbers. So equals sum. And so this number represents the value that goes here. Now this one is different. It's the sum of x, these numbers, that value squared. So we'll use that value later. And then if I look over here, I need the sum of the squares of y. So I want the y values squared. So equals the y value squared. And I just copy that down and equals sum. So I want the sum of that. And so these 5 numbers represent the 5 values that I need for this formula here. And I'm going to show you how we're going to write this out and set it up too. So, hold on. So this value, actually here, let me just write it out. That'd probably be easier. And this is, I'm going to show you how to do it in the calculator as well, but this is more or less how we would do it if we were doing it by hand. So if I wanted to calculate this by hand, right? So the value of n is 5 because there's 5 pairs of data. And then my sum of x times y is this number, 16,558, minus the sum of x. So the sum of x is this number, 883, times the sum of y. So the sum of y is 79. And that's just my numerator. I can calculate that value and get a number and kind of write that down as a, kind of simplify the numerator. In the denominator, and I like to use a lot of different colors so it's not looking like I'm just writing the same thing, but the entire denominator is square rooted. And if we look here in the first part, it's a bracket and then it's n again. So I have 5 times the sum of the squares of x's. So that's this value here, 180,495. 180,495. Minus the sum of x. So this number squared. So minus 883 squared. And then that expression is closed. And then we move on to the y values. So I have the value of n again, 5, because there's 5 pairs of data, times the sum of the squares of y, so 2,095, minus the sum of y squared, so minus 79 squared. Now, I know that this is a very tedious calculation, and the reason why I used Excel to get these numbers, because I didn't want to go through and do 105 times 5, 285 times 15, 151 times 8, 230 times 41, 112 times 10. I don't want to do that by hand. I'm a little lazy. Most mathematicians are lazy, so it's okay if you get a little lazy as well. there's no need, and really this process is going to be very simplified later when I show you how to do it in the calculator. I just want you to appreciate the ease of this calculation when you don't have to do it by hand after you see me do it by hand. So now that I have all that information written out, what I'm going to do now is switch over to my TI-84 calculator and show you how you can enter this in the calculator. So this calculator is available for download. You can certainly download this to your desktop, and you can use this on your assignments and as well as your test. If you have a computer, I know some of you indicated in the survey that you didn't have a computer. So you know what? I think what will be easier probably is let's just use Desmos. I like Desmos. It's a nice little utility. So if you go to desmos.com, you can either do Start Graphing or Scientific. Scientific would probably be best. It is actually nice because you can see the entire calculation. You don't have to worry about, in the calculator, the window is so big. Once you type anything larger, it starts to shift things over. This, you don't have that problem. So I think Desmos may be the way to go for us. So I'm going to use this and then try and get your feedback to see if you like the functionality. You can actually download this to your phone for free in the App Store or the Google Play Store. You don't have to pay for anything or download something to your computer. So we might just go with this. So we'll see. So I want to type in what I just wrote out. So I hit this a divided by b, creates a stacked fraction. And in the numerator, it was 5 times, and I have to go back and forth because I didn't retain all that in my mind, 16,558. So 16,558 minus the sum of the x's, 833, times the sum of the y, 79. Now it has this because right now you haven't put anything in the denominator. Once we start typing information in the denominator, it will start giving us a value even if we're not finished. So if I put a 2 down here, it starts to give me an answer. And as I type more values, it just changes the answer. So we have to be very aware of what we're typing in here, make sure we're being accurate. So let me go back and double check. 833.79, that looks good. On the denominator, both the expression in blue and the expression in brown or mustard, whatever color you see, that whole entire expression is in the denominator. So when I go back, I'm going to do square root, and then I think you can do brackets. I think you can do brackets. Let me see if I put a 2 here. Nope. So only use parentheses. So we can only use parentheses. 5 times, if I go back, 180,495. So 100, and that's a problem, switching back and forth. 180,495 minus 883 squared. And actually, I probably should have used the right button. You're going to use this one, squared. And so right now, it's giving me an answer, not the correct answer yet, because we don't have the value for, we don't have y. So notice, instead of me using brackets, because if I were to use brackets here, and I'll show you, it's not going to recognize this like we want it to. It thinks it's an element. It doesn't actually, it's not actually evaluating it because brackets in this utility mean something different. So instead, we're going to use parentheses in place of those brackets so that it actually performs the operation. So now for the y value, 5, and then it was 2,095 minus 79 squared. So this value that we have here, this is our correlation value, 0.57. If we go back to our presentation and we see 0.57, it is positive. So we know that if we were to graph it, we would expect the values, the points to be increasing. It's a moderate increase. It's a little bit over 0.5. So remember, anything from 0.5 to 0.75 is more moderate. Anything above 0.75 starts to get to the stronger area. The closer we are to 1, the stronger it is. So it's a moderately positive relationship. Now, what I wanted to show you, so if I go back here, .57. So if we describe the nature, if I go back to the problem, it wanted us to describe the nature of the relationship. So R, what I wanted, R equals 0.571. Since R is 0.571, there is a moderately positive relationship, or we could say correlation. And that's between the longevity and the gestation for a random sample of animals. So between longevity, which is the lifespan, and gestation for a random sample of animals, not from. Now, one thing that we want to look at is how do we simplify that process. I know I spent quite a bit of time showing you that, and I don't necessarily expect you to conduct the calculation that way. I want you to be able to find the value accurately and also be able to interpret the value. So I'm going to show you an alternative, two alternatives actually. If I go back to Excel, Excel's a wonderful tool. It has a lot of built-in programs that you can, or built-in functions you can use, built-in commands like I was doing with finding the sum of each of these very quickly. I just typed in, if you look up here, equals sum, and then selected the numbers I wanted to add. When I wanted to find the product, I could have typed in equals product, I believe, but it's just more easier just to do equals and then what I wanted to multiply. I can actually find the correlation value in Excel too, very quickly, just like we did by hand. Or quicker than we did by hand, actually. So equals COR, and it only returns one function. So this f of x is a function, and this returns the correlation coefficient between two data sets. So if I hit tab, it's asking me for information. It says array 1. What's the first set of data? So I select all of the values from x, put a comma, and then it says, what's the second set of data? I select all values for y, close it, enter, and look at that. The same value we found during this process over here, and I'm pretty sure you're thinking, well, why do we spend 10 minutes going over that? So you can appreciate not having to do it later if you choose to use Excel, or if you choose to use I'm going to show you how to find it on the calculator as well. Also, if we switch the values, so if I do equals COR, and if I choose the y value first and the x value second, we get the same value, right? It's the same relationship in both directions, so it's not going to change anything. We still observe the same strength and the same trend, more or less, from that value. So it's still moderately positive. When we plot the data on a coordinate plane, we expect a positive association. We expect it to go up. I guess I'll show you here at least, because I actually have a graph of it. So it's not a very strong relationship. So this line that we'll talk about in section 2 is called a trend line. And what we like to do is best estimate the trend of the data using regression analysis. In this case, we found the correlation coefficient, and then in the second section, we'll find the equation for the data, and we're trying to best estimate, the trajectory or the path of these points. And because none of these points are actually on the line, and these points they're more clustered together than these 2 points. These 2 points are actually greatly affecting this correlation coefficient. If we were to remove this point, we'd actually have a higher correlation coefficient because that point is what's making the correlation coefficient a little more moderate. So if I go back to my Excel and I take away that particular point, so it's the one between 200 and 250, goes up to 41, this one. If I remove this one, I have a higher correlation, right? Because that point is affecting the other points. The other points are more closely related, and that point's like the oddball out. So I get an even more precise or even more accurate relationship between the gestational longevity without that particular sample value. But we want to keep that there. So alternative, let's say you're like, oh, I'm not really liking Excel. I'm also not liking it by the hand way. That's okay. Now I will show you this. In order to use the calculator to find the correlation value, you will have to turn the feature on. There's two ways you can turn the feature on. If you have a newer model, you can hit mode, and then you have to go all the way down to the bottom, and where here it says stat diagnostics, it'll be off. You have to turn it on. So you have to go over, turn it on, hit enter, and then it'll turn it on and it'll give you the information when we need it later. If you have an older model, you have to access the calculator's catalog, and to do that, it's second and 0, and you just have to basically arrow down until you find, I guess you could probably arrow up, would be easier, I think, because it's in the S's. You want to find stats diagnostic in the catalog. Well, I thought it was easier. But you want to basically just keep arrowing up or down until you find the stats diagnostic option. So it'll be in the S's because it's alphabetical order. Well, I assume this would be quicker, but this might be quicker. We're almost there. Look, we're at the T's, so it's looking up, literally. So summation, there we go, store, stop. Now in this calculator, it may not be in this catalog because it probably is not in here, because it has it here in the mode. Because I have it here in my mode option, it may not be in the catalog. On the older calculators like the TI-83, this is an 84, it'd be in the catalog option. So if you have an 83, check that out. But now that I've typed it on, I would go to stat and I would go to edit. So number 1 from this list. And I want to type in some data. So I already have data in there. I'm going to do clear. And then I'm going to type in, basically I'm going to reproduce that table that we just typed into Excel. So 105, 285, 151, 230, 112. And the Y values, 5, 15, 8, 41, and 10. So that's my table. We got to reproduce this information in here. And then I want to go back to stat. And this time I want to calculate. And I want to calculate one variable statistics. Actually, no, I don't. I want to calculate number 4, linear regression. Number 4, linear regression. In section in section 2, we'll do this for the equation, but we can do it now in section 1 to find the correlation value. So here we see the correlation value point, and it's the same number that we found using Excel, the same number that we found by hand. So that's our correlation value. That's another way you can find it. So you have the 3 or 4 different ways that you can find the correlation value. So hopefully that wasn't too bad. It took a little while, but hopefully it wasn't too bad. So let's look at another example. We'll find the correlation value here, and I'll show it using Excel, and I'll also show it in the calculator as well. I'm gonna pause this first so I can enter the data, and then I'll come back. All right, so for our second example, we want to determine the nature of the relationship between robberies and murders for the data in the table. So here we have our independent quantity is murders, our dependent quantity is robberies, and it says the number of murders and robberies per 100,000 population for a random selection of states is shown. Is there a linear relationship between the variables? So one way we can do that is we can plot the data on a coordinate plane, make a scatter plot, observe the trend from the scatter plot. Another way is also to find the correlation value. The stronger that R value, the closer it is to +1 or -1, the more linear the relationship is. The more stronger the linear relationship is. So what I've done, I've entered the data into Excel. All right. So I just copy and pasted it. In all of your homework assignments, you can download the data. I've showed that in one of the videos. You just click download and it will download a copy of the data to an Excel file and you can manipulate it there. And so to save us time, I won't do the formula again. I'll just do equals COR tab. It says array 1. So what's your first list of numbers? Murders, comma, array 2. What's your second list of numbers? The robberies. And then this is my correlation value, 0.804, which is pretty strong. It's up there. It's closer to 1 than the previous value was. This is a positive number, so we know there's a positive relationship. And it's over 0.75, so we're going to say there's a more or less strong. It's now becoming, it's moderately strong. So it's not moderately positive, it's moderately strong. We would really like to be above 0.9, 0.95 to just definitely say, oh, there's a strong relationship. This was more moderately strong. In your homework, you don't actually have to use the words moderate or strong. It's just either positive, negative, or none. Very basic interpretation. Now, if I were to do this using the TI-84 or any kind of graphing calculator utility, I've already typed in the data because I don't want to go through that tedious process in the video. I already spent a good portion of the time talking about the formula and showing you how that works. So I've entered the data into the list, list 1, list 2. Remember that was stat, and then edit, and then type the information in the list. And then I go back to stat, and this time over to calculate, and I want to do number 4, which is linear regression. We're going to end up doing linear regression in section 10.2, but for 10.1, we need linear regression for us to do the correlation coefficient. Now, you won't ever have to change the X list and the Y list unless you type your data into a different column in the calculator. So my X list was typed into the first column, my Y list was typed into the second column, and I don't have to store the equation because I'm not going to graph it. I suppose I could. That'd be for the second section, and then calculate. So this is the correlation value, R. R squared is the coefficient of determination, and we don't really need that value per se. We only really need the R value. This also tells us the percent of variability. So R squared is the percent of variation between the X and Y value. So there's about a 64% or 65% of the variation can be explained in the relationship between the X and the Y. But for us, we just have to be able to find the R value. So 0.80 is our R value. And then now we go back and we can determine the nature of the relationship. And we can describe if it's linear or not. So that part we can do. So since R equals 0.804, so let's say we have to round it to 4 decimal places. There is I'm just going to say moderately strong, positive, linear relationship between the number of robberies and the number of murders between and this is only for the selection of states. And so just kind of to reiterate this, the R value here is what is giving me this interpretation. The R value is positive, so I say positive. The value is greater than 0.75. Less than 0.9, so I can say moderately strong. And more or less, we can say there's a linear relationship here. We can also look at the graph. So if I look at the graph, there is an upwards trend in the data, so we can see that. And this is our trend line, which we'll talk in more in detail in the second section. But the points, the data is closely related to the trend line. It's closer to the trend line than in the previous scatter plot example. So it has a higher correlation value. Those points are all more or less following the same trend, more so than the other one. So hopefully if you have any questions or any concerns when you look at the homework, feel free to either hit that Ask My Instructor button or shoot me an email, and I'll get back with you as quickly as I can.